sklearn, neighbors, sort graph by row values. Description. The sort graph by row values function is used to sort a connectivity graph. This graph represents the connections between data points in a dataset, where each row of the graph corresponds to a data point and the columns represent the indices of its neighbors. The function sorts the graph by the values in each row, arranging the indices of neighbors in ascending order of their distances from the data point, represented by the row inputs. Graph. A connectivity graph. This is typically represented as a NumPy array or a SciPy sparse matrix, where each row corresponds to a data point and the columns represent the indices of its neighbors. Outputs. Sorted graph. A sorted connectivity graph, where the indices of neighbors in each row are arranged in ascending order based on their distances from the corresponding data point. Steps. The function iterates through each row of the input graph. For each row, it sorts the indices of neighbors based on the corresponding values in the row, which represent the distances between the data point and its neighbors. The sorted indices are then used to reorder the columns of the graph, resulting in a sorted connectivity graph. Visualization plots. The sorted connectivity graph can be visualized as a heat map, where the rows represent data points and the columns represent their neighbors. The color intensity of each cell can represent the distance between the corresponding data point and its neighbor. The sorted graph can also be visualized as a network diagram, where each node represents a data point and the edges represent the connections between them. The edge thickness or color can be used to represent the distance between the connected data points. Fine-tune parameters. None. Uncertainty methods. The sort graph by row values function does not directly address uncertainty. However, the underlying distance metric used to construct the connectivity graph can have an impact on the uncertainty of the sorted graph. For example, using a metric like Euclidean distance might lead to different results compared to a metric like Manhattan distance. Challenges and fixes. Challenge 1. If the input graph contains duplicate values in a row, the sorting might not be deterministic, meaning the order of neighbors with identical distances might vary across different runs. Sample use case that resulted in challenge 1 when using a distance metric like Manhattan distance. Multiple neighbors might have the same distance from a given data point. Fixes to challenge 1 to ensure deterministic sorting. A stable sorting algorithm can be used, which preserves the relative order of elements with identical values. Challenge 2. The performance of the sort graph by row values function can be impacted by the size of the input graph. For large datasets, sorting the graph can be computationally expensive. Sample use case that resulted in challenge 2 sorting a connectivity graph with millions of data points and thousands of neighbors per data point can take a significant amount of time. Fixes to challenge 2 techniques like using a parallel sorting algorithm or exploiting the sparsity of the input graph can be used to improve the performance of the sorting process.